7.5, division rules or division properties of exponents. So if we're going to review a second, we had a to the m times a to the n. It was a to the m plus n. We just added those. But if it was a to the m, that whole quantity raised to the n, it was a to the m times n. So that's a very short little review of what we did. Let's talk about dividing exponents with the same basis. So let's write out 4 to the 5th. It's 4 times 4 times 4 times 4 times 4 divided by 4 to the 3rd. 4 times 4 times 4. Again, 4 divided by 4 reduces to be 1, so that set's gone. Here's another set I can get rid of because that's 1, and a third set I can get rid of because that's 1. So it ends up just being 4 times 4, which is 16. So 4 to the 5th over 4 to the 3rd ends up being, let's rewrite this as 4 to the 2nd, which is 16. And let's do x to the 8th over x to the 3rd will be 1, 2, 3, 4, 5, 6, 7, 8 x's over 3 x's. So those cancel out, those cancel out, and those cancel out, leaving us with x to the 1, 2, 3, 4, 5. X to the 5. So let's look at that pattern. We had x to the, 4 to the 5th over 4 to the 3rd gave us 4 to the 2nd. We had x to the 8th over x to the 3rd, which gave us x to the 5th. We're not adding like we did when we multiplied. Remember, we multiplied, we could add the exponents. This time, what are we doing? What is, how do I get from the numbers 5 and 3 and end up with a 2? It's subtracting the exponents. So that's the rule that we're learning. When we divide, it's the same as subtracting the exponents. So it's be a to the m minus n. We subtract those exponents. And then, so that's a rule. We have a power raised to a power, which is a to the m times n. We had just straight multiplication, which was a to the m plus n. So those are 3 rules, 3 good things to memorize, but instead of just memorizing, let's think about what they mean and then learn how to do the shortcut. So again, let's write it out. We have m times m, that's m to the 2nd, and n times n times n times n to the 4th, over m to the 5th, and n to the 3rd. And if I can find, let's see, this m on top cancels with an m on the bottom, that because m divided by m, 1. These would be gone. I just have 2 that are gone. Then I have n's, so let's see, n on the top, n on the bottom reduced to be 1. This one reduces to be 1. This one reduces to be 1. And it looks like on top I got rid of everything but a lonely n. And on the bottom, I still have m times m times m, and now I'm going to put it back together, which is m to the 3rd. So m to the 2nd over m to the 5th, if you just look at that part, I think of it this way. We have more m's on the bottom. The 2 on the top are going to cancel with 2 on the bottom, leaving us 3 on the bottom. And if you look at the n's, n to the 4th, we have 4 on the top, 3 on the bottom, so there's more on top. So I'm going to leave some on the top. And how many? 3 of the ones are going to cancel out with 3 of the ones on the top, so there's only 1 left. Next question. We just take things one at a time. I have 27 divided by 3. I know that is just 9, right? So 27 divided by 3, 9. So those are gone and simplified. Let's move our negative exponents to where they are supposed to be. So I'm just going to draw a long fraction bar. If I look on the top, x to the negative 2nd is going to have to move, but y to the 4th will stay right where it is. But I'm going to move x to the negative 2nd into the denominator as x to the 2nd. So that took care of my numerator. And then I'm going to look at this. So x to the negative 6, which is in the denominator, we have to move it. So it has to go upstairs, x in the numerator. Lose my negative sign, so it's x to the 6th. And y to the negative 5th is in the denominator, so it moves to the top as y to the 5th. Now I think we have everything moved. Let's see if we can simplify things. That 9 is still going to be just a 9. I'm going to put my y's together, so I have y to the 4th times y to the 5th, x to the 6th in the numerator, and x to the 2nd in the denominator. Let's see, I have 9, y to the 4th times y to the 5th. Remember, we add those numbers because it's 4 of them and then 5 more of them, so it would be y to the 9th. X to the 6th divided by x to the 2nd. I have 6 of them on top and 2 on the bottom. These 2 on the bottom are going to cancel out 2 on the top and make this 6 a 4. So I have x to the 4th. So this would be my answer if that's simplified. Let's do it with scientific notation. 6 divided by 3, we can just start with that. 6 divided by 3, which is 2. So I'm going to worry about this. 2. And then we have times 10 to the 7th on the top. And we have 10 to the 5th on the bottom. So these 5 are going to cancel out with 5 of these and leave me just 2 because it was to the 7th. So the answer is going to be 2 times 10 to the 2nd. And when I look at this, we could approach this a couple of ways. Let's put it in scientific notation first because that's good review. This 0.4 is not going to help our scientific notation. I need this to be 4. If I make that number bigger, this number has to be smaller yet. So I'm going to rewrite it as 4 times 10. Smaller than negative 2 would be negative 3. And again with this, I'm going to have to move this decimal 1 to the right, which means I have to make this 1 smaller. So it would be 3 times 10 to the negative 4th. And 4 divided by 3 is going to be 4 divided by 3. It's not a pretty thing. It's 1.3 repeating. But let's just write 1.33 so far. 10 to the negative 3rd over and 10 to the negative 4th. Let's move those around. So my 10 to the negative 3rd is going to be 10 to the 3rd in the denominator. My 10 to the negative 4th is going to be times 10 to the 4th in the numerator. So again, these 3 10s are going to cancel out with 3 of these and just leave 1. So I will get 1.3 repeating times 10, or 13.3 repeating. Okay, my smartboard is pausing. So let me see if I can pause. Okay, hopefully it's going to work now. I paused it for a second, but so again, let's look at some rules we're reviewing. This you have to distribute. So you have a to the n, b to the n. So here I also would have to distribute to both of them. So I'm going to distribute this here and down there. So it's a to the n over b to the n. So it has to be distributed both to the numerator and to the denominator. Because if you think about it, it's a over b times a over b times a over b n times, I just don't know how many times that is. But so I do multiply both the numerator and the denominator by that n. All right. So again, we have to distribute the 3 to both pieces. So this would be x to the 3rd over y to the 3rd. And here I have to distribute to both places, but let's just think about when I distribute here. That's z to the 4th raised to the third power over 5 to the third, which equals, remember when we have a power raised to a power, it's a multiplication. So it's z to the 4 times 3, which is 12, over 5 to the third, which is 5 times 5 times 5, or 125. And we have to distribute that not just to the numerator or the denominator, but to every single thing in it. So I'm going to do it to the 4 and to the x. So I have 4 to the second, x to the second. And then I also am going to do it down here. So I have over x to the third raised to the second, which is 4 to the second, 16. I have x to the second over x to the third raised to the second, so that's multiplication, a power raised to a power, x to the sixth. Now I can simplify because I have 2 x's here and 6 in the bottom, so I'm going to get rid of the 6 and change it to a 4 because I canceled the 2 from the top. And you get 16 over x to the fourth, and I am going to show you another way to do it. So that's one way. Here's another. I'm going to simplify before I distribute. So if I look at what's inside the parentheses, I can simplify it because this 1x will cancel out with one of these x's and make that a 2. So inside I now have 4 over x squared. And that's all raised to the second. So I still have to distribute it, but I don't have to distribute to twice as much, or to quite as much, excuse me. 4 squared over x squared, which equals 16 over x to the second times 2, which would be x to the fourth. All right, this time I'm going to just simplify first because I like to do that, and it's inside the parentheses, so that makes sense. There's p to the first here. So there's 1p in the denominator. That's going to cancel with one of these p's in the numerator. 12 over 15 can be reduced because I know 3 goes into both of them. So 3 goes into 12 4 times, and 3 goes into 15 5 times. So I got rid of the p in the denominator, but I still have 2 p's, or p to the second, excuse me, in the numerator, and that's now raised to the fourth power. If I would have left 12 over 15, the numbers would have been really big, and we would have had to simplify something bigger, and why bother when we don't have to? So now we can distribute 4 to the fourth, distribute here. We have p to the second raised to the fourth, and distribute to the denominator, which is 5 to the fourth. So we are going to get big numbers because 4 to the fourth is 256. And this p to the second raised to the fourth, power raised to the power is multiplication. So p to the 2 times 4, or p to the 8th, over 5 to the fourth, which is 625. So we have 256 divided by 625, and that can't be simplified, so that's just going to be our answer, 256 p to the 8th over 625. So review, negative exponents, move it and lose it. 1, it's in the denominator, I have to move it to the, it's in the numerator, I have to move it to the denominator. So it's 1 over 7 squared, which is 1 over 49. You should try these on pause before and then come back to see if you're right. 2 over x to the negative third, I have to move it. So I have 2x, and I have to lose the negative, so 2x to the third. That 2 doesn't move because it doesn't have an exponent on it, it just stays 2. Let's see, this one, can we simplify inside? No. So I'm going to distribute that negative 3. So I have 2 to the negative 3, x to the 6th to the negative 3, over y to the 4th to the negative 3. 2 to the negative 3, I know that's going to be 1 over 2 to the 3rd. X to the 6th raised to the negative 3, power raised to a power, multiplication would be x to the negative 18th. So it's going to be 1 over x to the 18th because I'm going to move it and lose it. Y to the 4th times negative 3, 4 times negative 3, which would be y to the negative 12th. So I'm going to move that. It's in the denominator now. I'm going to move it to the numerator and change it to y to the 12th. So I could flip that over to begin with. Have 5b over a. Let's give this a try. And then have it raised to the second. Because I moved everything and lost that negative. So now it would be 5 to the second, b to the second, over a to the second. 5 to the second is 25. B squared over a squared. Let's try it the other way. If I distributed that negative 2, it would be a to the negative second. And distribute it down to the denominator. 5 to the negative second, b to the negative second. So I'm going to move everything and lose it. So the a to the negative second, the numerator, is now a to the second in the denominator. 5 to the negative second in the denominator now moves to the numerator as 5 to the second. B to the negative second in the denominator moves to the numerator as b to the second. And that's exactly what I had right here. So you can flip it and do the that way, or you can distribute the negative first. Either way is fine. So our rule, distribute. Our rule here, distribute. Our rule here, we can flip it. And then distribute. So that was, I already showed you multiple ways. So we learned division is the same as subtraction. That's one way of thinking of it. Excuse me, division is the same as subtracting your exponents. So this is n to the -1 minus a -4. That's one of the rules. I don't like that rule because rules are hard to remember. I like to just think about what it really means. But this would give us n negative, subtracting a negative is adding a positive. So that would be n to the third. Or we can put this in the numerator. N to the -4th, it moves upstairs. N to the first moves down. And now I know this one cancels with one of those and gives me n to the third. I just think that way makes a lot more sense than doing it, learning the rule. So this one too. Oh, I just did it both ways in one spot, so. All right, that is it. Math rocks my socks off.